Hi everyone, welcome back. This is the software portion, the R examples for lecture 12, adding predictors and interactions in MLM. In this lecture, I'm mostly going to focus on the interaction side of thing. We talked about adding predictors last week. There's not a lot of change there in terms of interpretation, so we're going to talk about this mostly in terms of interactions. So what I'm going to do is first, before we start, I'll load the packages I need, LME4 for multi-level models, Elmer test to give me some p-values for my multiple models, and the interactions package for plotting and probing my interactions. I'm going to read in the data. We're going to use that Snyder's and Bosker's data that we saw before. So as a reminder, this is students nested within schools. This is where we have the language test scores and verbal IQ. We can look at a summary of the data. There's a lot of information we're interested in. Specifically in our case, we need school number or level 2 identifier. Verbal IQ is our predictor. Language post-test scores are our outcome variable here. And then group size is going to be our moderator. If we look at just the head, one of the things I want to point out is group size is a level 2 variable. It's the size of the group that students were tested in. So it's the same for all students in the group. If we get a quick summary of group size, we can see the minimum, median, mean. Where the mean is 23.10, standard deviation 7.29. So if we wanted to plot and probe our interactions at the mean and plus or minus 1 standard deviation, the mean plus 1 standard deviation is 30.39. The mean minus is 15.80. And I've got this, I don't know why I have this in the code, setting minority to a factor variable. I'll do it, but I don't think we're going to use it in this code. Let's do this first with regression. If we were fitting this a model where we're looking at here language post-test scores predicted by verbal IQ and group size. I have that. This is what we call my main effect. M0 here is what I call my main effect. So this model will tell us when we fit it. Here, these coefficients tell us IQ and group size. Holding constant the other, what is the effect of each? So holding constant verbal IQ, what is the effect of group size? And this says as group sizes get bigger, language test scores go up. Verbal IQ says as your verbal IQ increases, language test scores go up, holding constant the effective group size. Now, obviously, this is disaggregated regression, and we know the p-values will be wrong, but I just want to, we're going to pretend that's not the case for the purpose of this. To add an interaction term in R, we replace the plus between our predictors with a star. So if we do this, IQ verb star group size, this will include both the first order terms, both the slope of verbal IQ and group size and the product, the interaction between them automatically. You don't have to create a variable or anything. If we do this, we now see that we have an intercept. These slopes of verbal IQ and group size, this is the slope of verbal IQ when group size is 0. And this slope of group size here, this is the slope of group size when verbal IQ is 0. And the interaction right here. And this is the interaction of the two. So here, p is less than 0.05, so we'd say, what does this interaction mean? Well, we could do this by hand if we want, compute simple intercepts and slopes. So I could say the simple intercept is the intercept, so the simple intercept is the intercept plus the slope of the moderator, here group size, times value of z. So for group size is 23, the simple intercept is negative 2.22 plus 0.44 times 23. That would be 9.9. The simple slope is the slope of our focal predictor, verbal IQ, here 3.35, plus the slope of the interaction term times the value of the moderator. So plus negative 0.03 times 23. So when group size is 23, my simple slope would be 2.66. And I could change these. I could instead do it at, say, the minimum value when there's 5 individuals in a group. If I did that, now the simple intercept is 1.98. The simple slope is 3.2. If I wanted to probe these, I can use the vcove command here, vcove and the name of my model, to get that asymptotic covariance matrix. I'm going to use the round function to round those to 4 decimal places so they're easier to read. But here I could see the variance of the intercept, the slope of verbal IQ, group size, and the interaction. We can use those. And so in our case, to test the simple slope, we need the variance of verbal IQ, the variance of the interaction, and their covariance. I need those three values to plug in. One thing to point out about this is the diagonal. So the variance of each of these, if you take the square root of that, if you take the square root of each of these, it will give you the standard errors. So if we go back here for a second, here are the standard errors for these values. If I look at the square root of the variances, it is exactly the same as those standard errors we see up there. So that's just a fun fact. Now, if we want to plot and probe in the interactions package, there's a function called sim_slopes, where you give it your model, the name of the variable that's a predictor, and the name of the variable that's your moderator. And those names have to be in quotes. And if we do this, we say now we get first information on the Johnson-Niemann interval. So when group size is outside of that interval, so group size is less than 75 or greater than 244, the slope of verbal IQ is significant. And it gives you a note for the range of observed values. So you can see all the simple slopes will be different from 0. And then we get simple slopes. By default, it uses the mean plus or minus 1 standard deviation. We can also plot the interaction. So interact plot uses the same options, and it will give us a plot of the interaction. This is, you can edit this and change it how you want, but this gives us a plot of those simple slopes. And finally, Johnson-Niemann, well, the first thing I'll put, it repeats the Johnson-Niemann from sim_slopes, and it also gives us that Johnson-Niemann plot. And if you want, there's an option in the Johnson-Niemann plot called mod range, where you can change the range. So instead of looking at here from 0 to 40, because it guesses based on your data what you want, I'll say 0 to 300. And the reason I do that is if I look at my plot that way, now what I see is, okay, now what we see is here's where simple slopes are significant. Between these two values, about 74 and 226, the simple slope is not significant. And that is because that value of 0 is in between the confidence intervals, and then it becomes significant again. There are lots of other options. If I have time at the end, I'll talk about a couple where you can change where you want to plot your simple slopes and things like that. But I do want to talk about fitting these models with multi-level modeling first. So the multi-level model version, we're going to use Elmer. We've got language post-test scores are predicted by verbal IQ and group size, plus a random intercept. I'm only going to use a random intercept here. And so this is our main effect model, which is looking at what's the effect of both verbal IQ and group size predicting language test scores. I look at my summary of that here. I don't know why it keeps giving me a scientific notation. That's an Elmer test funkiness, but the slope of verbal IQ is 2.485. The slope of group size is 0.089, very similar to what we saw before. You can see p-values, they're both significant predictors. So as verbal IQ grows up, so does language test scores. As group size goes up, so do language test scores. Fine. And so to test the interaction instead, I just put a star in here. If I look at the summary now and so the slope of the interaction is 0.0273. And we can see it is, the p-value is down here. That p-value is significant. If we want to make it prettier, we can do this. We can see the p-value, we can see the interaction is significant, so we'd want to plot and probe it. And we plot and probe it exactly the same way. sim_slopes is smart enough to say that, okay, this is the result from a model you fit with Elmer instead of one you fit with regression, but it plots and probes them the same way. So M2, it gives us our Johnson-Niemann interval, same interpretation. It gives us our simple slopes at the mean plus or minus 1 standard deviation. We get the same plot of our interaction. And we can also get that Johnson-Niemann plot that we saw before. So I am going to look up really quickly. Form of simple slopes. You can see there are lots of different options. One of them is mod X values. So, and all of these will work with through interactions too, I want to mention. Mod X values is null. As you see, null, the default is mean plus or minus. So you can, there's terciles, which splits the data in equally sized groups, the mean of each of those groups. That's a new one, or you can give it a set of values. So I could here say, mod x dot values. I could say do it at 5, 23, and 37. I could do it at the minimum, the median, and the maximum. And if I do that, I would get now simple slopes when group size is 5, 23, and 37. Note, your choice of simple slopes will not affect the Johnson-Neiman interval. That Johnson-Neiman interval, that estimate, has nothing to do with the values you pick for simple slopes. But you can pick different values with that mod x values option in simple slopes. I'm going to stop there for now. One thing I'll remind you of, if you have a significant interaction, always plot and probe it. Look at those simple slopes, the Johnson-Neiman technique, describe those, report those. You don't always have to have a plot of them, but you always want to describe and report and interpret the simple slopes. And so just to interpret briefly here, it looks like as group size goes up, the relationship between verbal IQ and language test scores gets weaker. So with small, when group size is small, there's a stronger relationship. The slope is 2.98, down to 2.49 to 2.11. So it may be that in larger groups, there's more of, say, a depersonalization effect or something along those lines, where individuals' personal sort of trait level ability is less predictive of the test score than the situation itself. And that might be something we might see. So if you have a non-significant interaction, you don't need to plot and probe. There's no information there that you need, so don't do it. I'm going to stop there for now. Thanks so much for listening. Please, post on Canvas, ask any questions you have, and I'll see what I can do to help.